Yeah, as Katarina said, my name is Joe Sepi. Thank you for having me. I am a developer advocate at IBM, and I wanted to talk to you today about serverless architectures, and particularly Apache OpenWhisk. So I'm super excited to talk to you about this. Serverless is really a pretty exciting technology. I know a lot of other developers are really embracing it, and I don't know. No, I'm good. I'm going to hang out here. Thanks. Yeah, so a lot of people are really excited about it. Some companies are moving parts of their architecture to it, and even some companies are moving completely to serverless. There have been some good talks out there from a gentleman from Bustle who they largely moved, I think, almost all of their architecture to serverless, which is crazy but awesome. So hopefully by the end of this talk, you'll be excited about serverless as well. You may remember me from earlier. That's the kickoff. So there's been an increasing abstraction away from bare metal over the years, and we're now at the point where new serverless platforms like OpenWhisk or Amazon Lambda, there are a variety of cloud function providers out there that enable developers to focus more on their key business logic, which is typically written as ever smaller pieces of code or functions, and they're less worried about the supporting infrastructure that underlies that. The term serverless has emerged for this deployment model because from the developer's point of view, his or her concerns have shifted away from that operating the infrastructure that supports the code. So microservices is a pretty popular approach to building applications, but as we can see here, it can become harder to manage microservices at scale. So, however, these new serverless platforms help developers build well-designed cloud-native applications that more easily can offload many of the operational best practices that are recommended by the 12-factor approach to building web applications. So this is particularly true in the areas of scaling, container lifecycle management, workload concurrency, and all of these things can quickly get out of hand once you go all in on microservices. So serverless helps you there. But there are also many other types of applications that really benefit from a serverless architecture and its cloud platform elasticity. These include data processing, IoT, chatbots, batch jobs. I'll show a couple of these in slides a little bit later, but these are good examples of workloads that are a good fit for event-driven models that serverless platforms provide through support for different protocols like MQTT and asynchronous, like non-request response interaction models. So this slide illustrates another great benefit of serverless, and that's money, right? So a new cost model is emerging along with these, with the code aspect of the technology aspect of the serverless architecture. And it's one that ties code execution time directly to the price that developers pay for the services. This is where the second aspect of the term serverless comes to play, as the code isn't sitting there running idly, which you would be paying for on a conventional cloud platform. So while serverless architectures aren't a silver bullet for sure, they do provide a new cost model and as well as developer tools and developer options for many use cases. So how can you actually start to develop and deploy these types of architectures today and begin to take advantage of these technical capabilities and their cost models? One great option is Apache OpenWhisk, which IBM started a couple of years ago. In fact, a good friend of mine, Roderick, wrote most of the code. He and his small team at this, the IBM Research Center, which is not too far from where I live, just north of New York City, put OpenWhisk together, and then IBM subsequently open sourced it through the Apache Foundation. So OpenWhisk is a flexible, extensible platform that integrates with a variety of internal and external event sources, which are its key differences from things like Lambda and Google Cloud Functions, Azure Functions, and such. So this slide is illustrative of how the serverless model works. I actually had a cute little animated one that the gears spun and stuff, but it wasn't working on the slide, so I ditched it. But as you can see here, OpenWhisk offers the developer a pretty straightforward model for programming based on these 4 concepts: packages, triggers, actions, and rules. So packages will provide event feeds. And as you can see on the slide, a few examples there. They're probably a little small, but like Kafka, the Weather Company, Slack, Watson, GitHub. There are a variety of event feeds that you can take advantage of. Those are associated with triggers, which fire when an event occurs. And then developers can map actions or functions, their business code, business logic, to these triggers using rules. So anyone can create a new package for others to use with OpenWhisk in this model. And developers can write their actions in any language. As you see up there on the slide over here, we have first-class support for languages like Python and Java, Swift, of course, Node.js. But you can extend OpenWhisk to use any language or platform because it's all built on Docker. So if you can containerize it, you can run it. So behind the curtains, there are servers that actually run your serverless code. Of course, you don't need to really worry about that, but if you were curious, this is what the model kind of looks like at a glance. We have Nginx, Console, CouchDB, Kafka, and Docker largely running the OpenWhisk platform. So you can take this model and run it locally on your developed machine, or you can deploy it on premises with OpenStack, or you can use a cloud provider such as IBM. So yeah, that's going to be kind of hard to see, but IBM Cloud provides a nice interface to running your serverless applications. You can get right in there and edit your code, run your code, send in different parameters and such. There's a really good editor and workflow for building actions and triggers and sequences and these sorts of things. There are really good debugging tools. You can see, like for example there, this Hello World code ran for 117 milliseconds. And the great thing is that that's all that you're paying for is that 117 milliseconds. A previous iteration of this UI used to show the startup and the shutdown of the actual container that's running your code, which I found kind of interesting because you don't pay for any of that. And it would just show you the milliseconds that it took to run your code. So I think it's a really great model for running your business logic. We also have really great monitoring tools built in, as well as logging. And so if you want, you can go check it out. If you click on that link, which I know you can't physically click on it, but if you do, I get $1, which isn't worth as much as €1, but it's worth something. And also, someone goes out and puts out a plate of food for the cats in Thessaloniki. So check that out. So if we look a little bit closer at the OpenWhisk programming model, we'll see some more examples, and now you might actually be able to see them because it's a little bit bigger. And I think actually if you picture the packages above that, the flow makes more sense to me. So you have things like Slack and whatnot. Slack's a really good example. There are a few, I'll show you some resources in a minute, but a good example is taking, so one that we've used in the past is you get a bug report into your system. That gets sent to Slack. That sends off a trigger, can process it using some sort of natural language processing. And then we'll if it's like a bug report, you can kind of triage it and prioritize it and then post it back to Slack is one of the examples that we have on IBM Code. So as you can see, there are the first-class support languages there, but we have Docker, so you can pretty much run anything there. And then, like I said, these sorts of triggers can happen. Social events. One of the things that I really like is the device readings and the location updates. So if you can think about like IoT implementations, that's a really great use for serverless architectures. Well, I'll get to that one later, actually. But if you think about IoT, it's a great way to, the event-driven model works really well for sensors and things like that. But also, data changes. Somebody makes there's an update to your data source. You can process it or do any sort of analytics or what have you. Or conventional user input from your web application, for example. And then the actions are the code that runs in response to these triggers. And again, that's like where your business logic is. And this is a great model to kind of get all the other stuff out of the way and really focus in on very specific parts of your application. And then you kind of abstract everything else away. And it's great for deployment, too. You need to make a small change to one aspect. You can just work on one file and deploy it, or go into the interface and edit it. It really kind of isolates and encapsulates the bits of your code that you need. So this is a simple example using JavaScript. The convention for OpenWhisk is to have a function called main, and to pass in an object with your parameters. In this instance, we're just grabbing a couple of params and doing some sort of hello world type thing. But this is kind of the convention. You would that's your entry point as your main function. And then, like I've said, you could use any programming language as long as you can package it up with Docker, your application with Docker. Here's kind of an example of composing actions to create sequences, to give you more kind of flexibility and allow you to create these sequences for use later on, or adapting them for other flows. And then you can do kind of a many-to-many mapping as well. The different rules can fire the same kind of trigger and things like that. And these are some more examples of how you may tie actions to triggers. And of course, in the bottom right, you can program your own feeds and packages. So normally, I would get into some live coding, but I'm feeling that's pretty dangerous. So I threw some stuff into some slides. You can download the OpenWhisk CLI by going to the Apache OpenWhisk site. You can see some of it there. It's openwhisk.org. Again, if you go to IBM Cloud, you can get it there. You can do your development in the browser as well. So this is the OpenWhisk execution model. Pretty straightforward. Trigger comes in, and you respond to it. This is a really basic example. You can see maybe the URL down there. And I think actually this is in the Apache Foundation now as well. But instead of actually live coding this, we have the code up on top there. So what we're basically doing is we use the Whisk command line interface to create this handler action based off of the handler.js file. So if you go to this repo and pull it down locally and run Whisk in your local repository, there'll be a handler.js file in there, and this will create the action called handler based on what's in there. And basically, that function up there, which may be a little hard to read, is in that JS file. And again, it's taking some params in, it grabs the date using JavaScript, and then basically console logs what time you're invoking that. So the second box, it's an example of invoking that action through the command line. You may notice the -- blocking. That's so that the asynchronous nature doesn't just run and shut down. We kind of wait for the response to happen, and you would see the output that it was run at whatever time that you ran it. But the third box here is us setting up a trigger. We're creating basically a cron trigger that will run every 20 seconds, and then we'll output the time each time that it runs. And we do a max triggers of 30, because it'll just keep going if you keep going. And then what we do here in the fourth box is we actually map that, or we create the rule that maps the trigger to the action. And then that kind of pulls everything together. And I don't have the code up here, but what you typically do is in one command line window, you can run a logger, an activation logger, and it'll pull and let you know what's going on. And then you can run this cron job, or set everything up, and you'll see in your activation poller the timestamps being emitted from this code here. So pretty straightforward stuff, and stuff that you can get working on right away. It's there's not a huge barrier to entry there. This is another example. You can't see it, but that's a CATS database. The internet's run on CATS, but apparently Thessaloniki is run on CATS as well. So here we kind of put in text and image into a Cloudin database, and we have a trigger associated with that change, and that would fire an event, read the change that had come through, and then perhaps write it to another data source. You can imagine a variety of use cases there. And again, the URL is there if you wanted to play around with it. And this is a slightly more complex example, but I think pretty basic and easy to grok. Here we have API requests triggering actions. So if you're posting to your CATS API, what have you, you can map these things directly to events and do what you like with them, really. And actually, in the IBM Cloud interface, there is a way to quickly and easily put APIs in front of your actions, so you can start building out your application pretty quickly and easily. These are a couple more examples. We have this one that's Open Fridge, related to IoT stuff. And then OpenChecks is another one that is a really good example that's a little bit more complex. I wanted to just take a quick minute and point out we have this new platform for sharing open source code and specific code-based solutions to common problems that can get developers up and running pretty quickly. It's all open source. Some of it's IBM specific, but most of it is you can use in a variety of ways. There's a whole serverless section that has a variety of solutions already kind of built out for you. There's typically a blog post and a video and an architecture diagram. We try to keep these things pretty robust. And this is one that I specifically worked on. My name's kind of small, but you can see it up there. This is an example of pulling together a few things, but the serverless aspect is basically we have an Acme Freight shipping company, and you can, using IoT, like track where shipments are, and based on weather events, you can process the weather event, see where your shipments are. If you need to reroute your shipment because of this weather event, the application will let you know that and even suggest an alternative route. So this is a really good, practical use case that people could start using right away. There's a blog post and all this other stuff. So as I mentioned, you can check things out on the IBM site or go to the Apache site. The OpenWhisk community is pretty large and active, so there are a variety of other resources out there as well. And I wanted to take one moment of your time to share this other initiative that IBM's just started called Call for Code. and it's an initiative to get developers working on some disaster preparedness, disaster response applications. We're working with the UN and the Red Cross and the Linux Foundation and a number of other great organizations to help build out applications for the natural disasters that we're seeing more and more these days. So if you're interested, check out Call for Code. Again, that feeds cats, right? And that's it. I kind of ran right through that pretty quickly. Too much coffee, but I know we're a little behind, so maybe that's okay. Thank you. Surprise, I'm done.
Yeah, surprise. So, in case you have questions, please raise a hand. Okay, now you can hear me. So, in case you have questions, please raise a hand. I see little hands raising up. No? I just have, okay, make it more visible so that I can see you in front of the lights.
Also, I'll be around, so we can chat later, whatever you need.
Yeah, we'll have the after party at Xarhacos. La Rosa Negra, right in front of the venue.
Which I heard we're going to do the limbo at.
Which is what?
The limbo? You know where you go underneath the stick?
Oh, no. I'm not ready for that yet. I will think of that maybe next time.
Hi. Yeah. I just want to see the link for the cats again.
Link for the cats?
Yeah.
There you go.
Thank you.
Thank you. Yeah.
Okay. Next question? Okay.
Oh, I don't know if I called this out, but let me just share this really quickly before we go on. Where did it go? I thought I highlighted it here. No? Okay, so if you Google OpenWhisk, awesome. There are all these lists on the website that are awesome lists for technologies and conferences and stuff, but the OpenWhisk awesome list is like a huge long page that has videos and blog posts and conferences. It's awesome, literally. So check that out too. I thought I had a slide, but I guess not.
Okay. So just one brief question, from me, to you.
Yeah. Is it about rock and roll or OpenWhisk?
No. If you want to talk about that, you can. I was going to ask you, because I'm visiting Saloniki, you're visiting Saloniki, what is the most outstanding thing that impressed you most about the city? Okay,
well, I love dirt bikes, so I love seeing all the motorcycles. But besides that, I actually really like seeing all the cats. And our hotel room is above this square block of ruins, and there are a bunch of cats living there, and my young son and wife are with me, and we play this game where we try to count how many cats we see in the ruins. It's really fun.
Okay, and what is the other country closest to Greece that you visited before coming here? What was the closest distance before being here?
I was in Vienna a couple of weeks ago for the We Are Developers conference, which was really great. Does that count?
Kind of, yes.
Yeah?
Okay. Yeah. And speaking about the coffee culture, because I admire the coffee culture in different cities. Was there anything specific and new that you found about coffee?
That's a very good question. Is it frappa or frappe? Yeah. So when I first got here, I asked for espresso, and then they're like, oh, we have this frappe thing. And I was like, okay, great, and I tried it. But are they always made with powder? Because I think a couple of times they made actual espresso for me, which I really like. But the powder one, meh.
I didn't have the powder one. Okay. Do you often have the powder ones?
Yeah, okay. I'm kind of an espresso nerd, so I try to find the ones that will make it with actual espresso for me.
Okay.
Yeah. Very good questions. You're good.
No, I'm just trying to find out more about you.
Yeah, I appreciate it.
And one small question, again for me.
Okay.
What was the age when you started to play the guitar? What happened first? You started to code or to play the guitar?
I was kind of late to code. I started guitar when I was 14 and coding when I was 20. Funny story, and I won't get too into it, but I thought that music would find me a career, and what ended up happening is my drummer got a laptop, and I was like, what's this internet thing, And I stumbled across ViewSource, and I was like, wow, that makes sense to me. I kind of like this, and I started building websites. And like you mentioned, I started working at Sears, and when I started working there, I was like, wait, is this a real career? What happened here? And so now, yes, Now I make money programming, and I don't have to worry about making money on music, because that's hard. That's really hard.
And like, if programming doesn't come to your life, what would you do other than music?
Ride dirt bikes.
Okay.
Thank you.
So thank you so much once again.
Thank you. A round of applause for Katerina, please. Doing a great job.